See why Levepex is different. This video tour of the brain shows how signals are sent through the nervous system, what causes seizure, and how Levepex can help. As you will see, Levepex affects a site in the brain that no other medication has been shown to affect. The billions of nerve cells called neurons that make up the brain talk to each other through a carefully balanced message system. Neurons pass messages to one another using electrical and chemical signals. But how do the neurons talk to each other? Electrical signals inside a nerve cell activate tiny structures called vesicles. Vesicles are small containers that store neurotransmitters, the chemical part of the communication system. Nerve impulses set these vesicles in motion. They are set spinning closer and closer to the border of the nerve cell, the membrane. When a vesicle touches the end of the neuron, the vesicle may fuse with the membrane of the nerve cell. The vesicle is now open to the space between the nerve cells. It can release its neuron transmitter into the space. The job of the neuron transmitter is to bring the message from one neuron to another, but a single molecule or even the content of one vesicle is usually not enough to pass on a signal. But not all signals are meant to be passed on. Some messages are important enough to go through, but others are ignored in the brain. This is so the communication system does not become overloaded, and the most vital messages can get through. It's like having a conversation in a crowded room. You try to tune out all the chatter around you. Because each nerve cell is connected to hundreds of others, it will only react if it receives enough signals from its neighbors. The message must be important enough to pass on through the brain. So how is the decision made to pass on a message? Receptors on the receiving neuron react to neuron transmitters by changing shape. If enough receptors change at the same time, the receiving neuron feels an electrical impulse and releases its signal to the next neuron in the chain. Here we see the system in balance. During a seizure, there is too much neuron transmitter and too many electrical signals. When neurons are firing continuously, the system is out of balance because more signals than usual are passed on. There is too much noise which disturbs the communication of useful information. This increased activity can spread as the signal is sent through many neurons, causing a chain reaction and an overload at the brain's communication system. How does Levepex help? Levepex directly targets the vesicles that contain neurotransmitters. As it attaches to the surface of these vesicles, Levepex may help control the release of neurotransmitters. This may reduce the chance of having too many electrical signals. No one at epilepsy medicine has been shown to working this way by targeting vesicles. Vesicles help control signals from one neuron to the next. Seizure control is about restoring the balance in the brain's communication system. Levepex is available in different forms: 500 milligrams, 750 milligrams, 1000 milligram, and oral solution. Levepex, the true novel anti-epileptic drug. Levepex.